Hey everyone, and welcome to my session, which is called Data on Microsoft Azure. And really, it's about understanding Azure storage, because when we think about storage, it's ultimately where some sort of data is going to rely on, or live on, I should say. And when we look at Azure, we have a vast amount of different offerings when it comes to the different storage types that we probably have already seen from a traditional standpoint, maybe on premises, and we think of that as object storage. We think that of block storage, SAN, and then we think of NAS. And there's a few others in between, but ultimately, those three are the fundamental building blocks of where we store our data when it comes to Microsoft Azure. So, the whole premise of storing that data within Azure and then taking advantage of some of those services within that. So, we think about that blob or object storage. When it comes to Azure, we have Azure Blob Storage, and really object storage over the last, I would say, 5 to 10 years has become a first-class citizen. We used to only talk about storage in the form of block and file, and I think when I first started in that operational background around NetApp storage, that really unified that architecture where we didn't have a SAN device and a NAS device. NetApp gave us both of those on-prem that allowed us to work with that. I've just realised that I haven't introduced myself. I'm Michael Cade. I'm a Global Field CTO at Veeam Software. And really the premise of the session is to hopefully educate that if we start off at that storage layer, or even when we think about cloud, we think about cloud as look, this is just compute, storage, and networking that we're taking advantage of, and we're offloading some of that responsibility over to that cloud service provider, and in this case that's going to be Microsoft Azure. So if we think about Azure Blob Storage, and this is really around, or Azure Blob Storage is really designed to store massive amounts of unstructured data. Its use cases are very varied. I mean, I work in the backup space, so I see a lot of our customers sending from on-prem into Azure Blob Storage. But equally, we might see static website content. We might see the media files. Organizations might leverage it for scalability around other intensive applications, such as high throughput access to large data sets. So an example of that might be an e-commerce platform utilizes Azure Blob Storage to store and serve product images. And the platform takes advantage of the Azure Content Delivery Network, for example, and that integration for faster content delivery to your users all around the world. Then we have file storage. So how do we take what we potentially know as SMB or NFS on-prem to store our documents, and we want somewhere in the cloud to be able to store that? Fundamentally, there's a couple of options in Azure, but really at the baseline, there's Azure File Storage, which provides a fully managed file share in the cloud. It is SMB from a protocol. I'll talk about how we can get NFS later on, hopefully, if I get time, using another variant within there. And this is really about ensuring that security is paramount. One thing that we might have experienced with on-prem NAS devices is God mode, you've all got access to everything. But where Azure File Storage comes in is that it integrates into Azure Active Directory, or the new artist known as Entra ID, to add that extra layer of authentication and authorization into what that storage what the access might look like. So let's look at an example. Let's look at so company securely stores sensitive documents. So that document store that I mentioned, your home drives, using Azure File Storage. And then by implementing Entra ID authentication and user profiles, the institution or the organization controls access to the files based on user roles and permissions. Group A can access this file, Group B can only access these files, not vice versa. Now, the other area that I haven't touched on when it comes to blob and now file kind of sits in between before we get to block is something called table storage. And we have to think of table storage as something very database centric around NoSQL, things like data modeling. And that's that Azure storage, which offers a NoSQL data store for semi-structured data. If you think about data in general, if you did a Google search for what is data, you're going to come up with three variants. You're going to come up with structured data, you're going to come up with unstructured data, and then you're going to come up with semi-structured data. And that's where the NoSQL or table storage is going to fit. And that table storage is ideal for applications that require high-speed access to large data sets, and that data modeling is key to harnessing the full potential of that table storage. It could be telemetry type data storage. So an example of that might be an Internet of Things platform utilizing Azure table storage to store and analyze sensor data, and then the platform benefits from the flexibility of NoSQL modeling, allowing it to adapt to the changing data structures and requirements. Along that same vein, my belief, and I'd love to get your feedback on this, so both table and the next one that I'm going to talk about, which is Azure Queue Storage, I actually believe sits on that object storage, on that blob storage that I previously mentioned as well. But let me know. That's my understanding of that. I guess all of these are also encompassed into a storage account. So when you go into your Azure portal, you create a storage account, and this is where you can spin up these different storage services within Azure, which is ultimately then where you store your data. So for Azure Queue Storage that I mentioned, and this is where we want to build scalable, decoupled applications, and the use case there around handling like asynchronous communication between microservices, managing task queues, and implementing just distributed processing. So an example of this might be of a company using Azure Queue Storage to manage order processing. As a new order comes in, they are added to a queue, and a distributed system of workers processes each order independently, ensuring that scalability. So think of this like a queuing system, a pub sub ultimately system type thing. Then we get on to, so there is a large part of the block-based storage, or actually the blob, the object storage, where there is a tipping point where we start to want to take advantage of things like data lakes. How can we put all of our scalable data lake, big data type analytics into a place? And Azure have Azure Data Lake Storage, which is another form of blob-based storage that enables us to have a hierarchical namespace. So things like Azure Databricks offers them capabilities around storing and analyzing vast amounts of data. So if you're a data-driven analytics company and you're using that Azure Data Lake Storage, I believe it's called Azure Data Lake Storage Gen 2 or ADLS G2 for short, to store and process large data sets, and that namespace that I mentioned feature enables efficient data organization. So that one step further, it's going to enable us to have that efficient data organization and seamless integration with Azure Databricks, and give you that analytics. So it's a step on top of what we see. And then probably the most used storage that maybe you're aware, maybe you're not, but any virtual machine that you've created in Azure, they use Azure Managed Disks, but there's a vast amount of use cases for or Azure Managed Disks. So Azure Managed Disks, and this is where we're talking about block-based storage, it's really about virtual machines. If you've used virtual machines in VMware, for example, you've used VMDKs, very, very similar. I think these are actually known as VHDs under the hood, but you don't necessarily see that. And this really handles that storage as a service for those VMs. And these disks with virtual machines involves considerations like choosing the right disk type. Most important thing I've got to mention here is that in the cloud, like when you're running VMs on things like virtual machine or Hyper-V on premises, then you're beholden, like you can make that 500 gig and it will be as performant as the storage underneath. With Azure, we might have a capacity and there'll be a defined amount of IOPS to that. And it doesn't matter how big that capacity is, but so you have to, so they play into each other in regards to that. Where before we would have been able to define our IOPS and the input outputs that we would get with that really fast disk on the disk array that we were using, and we would make it the same, as much as capacity big or small as we wanted. So if you're thinking about like what are the use cases for virtual machines in the cloud or in Azure, well, one is what's happening at the moment with on-premises virtualization, licenses, costs, etc. There might be an appetite to move your virtual machines and ultimately your data that lives on those virtual machines into Azure. And as you do that, you're going to be using the Azure managed disks, and they choose these premium managed disks for very high performance. And I will say they have a very similar construct to what we see on-prem around that first like snapshot capability within. As I come from a backup background, I'm going to suggest that a snapshot is a very fast recovery point and it's going to get you out of trouble, but we should be looking at how we can ship them backups off into object storage as well for a longer term retention and not rely on a snapshot. I think also one thing to consider here is that we also have things like the Azure Storage Explorer. So how can I see what's happening? And we have that, I believe, from the portal, as well as a UI that we can download onto our systems. So think about that as an admin. Your daily task might be using the Azure Storage Explorer to drag and drop functionality, simplifies file transfers, etc., between maybe on-prem and the Azure storage grouping that you've touched on. The other interesting part that I'm probably taking more time to learn about now is around that hybrid cloud storage solution that we can have between our on-prem and our Azure account. Not everyone has done that big lift and shift. So where we have that hybrid cloud environment, Azure still offers great solutions for seamlessly integrating to on-premises storage with the cloud or the Azure that I've just previously mentioned. So choosing that right hybrid cloud strategy really involves and considers things like Azure Store Simple for tiered storage and Azure File Sync for that file synchronization. So if you think maybe traditionally we would have a virtual machine or a physical machine on-prem, or maybe even a NAS device, and we would have several tiers to that within a cluster, they would replicate changes between that whole file namespace, if you will. Now we're just adding a cloud version of that. So now we've got a copy of our data up in the cloud, which then opens up the door to access. And one of the things that we've seen, especially since the pandemic, is the ability to break down the four walls of the data center. And how do we actually give access to our users that are now remote, if that is what's happened and not everyone's gone back into the office. But this will give you the ability to break down those four walls of the data center that you maybe once had, and now you can get the throughput, the elasticity of the public cloud, and still provide access to those files through a secure authentication model such as Entra ID, giving you that functionality. And I think all the way through these different examples are really around just proving like everything that we really touch within Microsoft Azure or any cloud, there is an element of data with it. And the reason why I bring this up is I've been doing a lot of work around the cloud native ecosystem, namely Kubernetes, AKS and ARO, but equally Kubernetes anywhere. And that whole stateless versus stateful conversation still comes up even in 2024. But ultimately, yeah, okay, you may choose to run your stateless workload within Kubernetes, and I'm not going to argue with that being the approach. But I will say that there will be, unless you're running static websites where everything is contained within the container and you're not using any persistent volume claims and you're not using any state within the Kubernetes cluster, then fine. I understand that. That's 100% stateless. However, when you start your application and you have some sort of authentication model, you have some sort of database that is maybe a back end to that, orders or catalog or some sort of storage. And granted, again, you might not be using a database or a data service within the cluster, but you are using an external database, and that might still be on a virtual machine, or it might be using something like Azure SQL. All of them are data, and all of them should have a consideration when it comes to, okay, what does a bad day look like, and how can I get out of trouble when bad things happen? And it might not even be when bad things happen. How do I migrate from a VM that is running Postgres into Azure SQL? Because I then take advantage of all of that offloading of management and admin overhead over to Azure at that point. And that might be an evolution of what you're doing inside your business. So if we think about Azure Store Simple, again, only really just found out about this, but if we think about a company implements a hybrid cloud storage solution, a Store Simple, they archive the historical data to Azure Blob Storage, again, leveraging that object storage location within Azure, reducing the amount of storage that we have on-prem. So we might have made a massive CapEx spend on some really expensive tin on premises, or we might be just sweating that asset that we don't want to store our data on there anymore. Well, let's take advantage of the colder data. Let's stream that through into object storage or blob storage within Azure, and that will provide that tiered solution. Then you've got the file sync that I mentioned. So imagine an architecture firm or a business using Azure File Sync to centralize project files across multiple offices or multiple locations, because now our architects, as this example states, are now at home and they're all over the country, all over the world. And by following best practice, they can achieve efficient file synchronization and reduce the burden on their on-premises file servers. Or you've gone completely all in on Azure, and then this allows us to do that as well. But maybe some architects are in a central office, some are remote, maybe one day you're remote, so you want to take advantage of that and use the most painless way about being able to access that file. So I think hopefully that was useful as a very baseline effort. So think about Azure storage. Where there's storage, there's data. Granted, there might be some long-lived databases, Azure SQL that I've mentioned, the ability about being able to offload that database, or that overhead of having to look after an operating system, the database, all the patching and everything with that. We can do that with a PaaS-based solution. Same from a file service point of view. We're really taking away that overhead of having to manage the tin that we might have done in our data center before. So we touched on object storage, great place to send our archive data, our backup data, vast amounts of data. Again, we're seeing a lot more customers not only sending their backup data there, but we're also seeing a large amount of production, like first-class data, having to be protected from that as well. Then we've got our file capabilities. So on that, I mentioned that I would come back. So NetApp have a first-party solution offering SMB and NFS with Azure. Think about the capabilities that you get with Azure Files are great, and if you only need a very simple SMB share, great. But if you need like the NetApp functionality, what you get from an ONTAP point of view, then maybe that's the level above that, and it brings you NFS as well. And then we're seeing things like applications then leveraging that NFS, things like Oracle and other applications within that. And then we've got our disk-based. Now, when we think about that disk or that block-based storage, we're not just thinking about VMs. I know I just touched on a scenario that uses disks for our virtual machines, and that is one of them. But if you think about that, it's a very powerful way in which, well, ultimately all of our databases live on that same disk, that block-based storage. Our Kubernetes storage or our Kubernetes hosts, which are ultimately just virtual machines in our account, they also use that managed disk scenario as well. So a lot of them are using that same storage service within Azure. The other thing to mention is that all of these, whether you want to provision them, or if you provision them inside your Azure environment, they all are under a storage account. You can have multiple storage accounts per subscription, per region. There's a whole, I made so many notes around things like resiliency, actually, that I should probably touch on. So if you think about your storage account, especially from a managed disk point of view, you have 3 different disk types that you can have. One is standard, one is premium, one is ultra. And this is where I will say again about that size and performance are tied. There's a really good website on the Azure docs where it states what the capacity would be and what the IOPS would be. It's not like it maybe was more traditionally on-prem. Things like an operating system disk would be a managed disk, so it would be persistent. Ultimately, I want my operating system disk to be persistent because when that reboots, I don't want it to lose it. But equally, I believe that on all virtual machines, there is a pool of storage available, but that isn't persistent. That is ephemeral. So you put something in there, you reboot, that's gone, or potentially gone. There's some risk and Notepad stuff in there. I believe that is the D drive, but it doesn't stand for data, but it sits on that local host. So if we think about Azure storage being that bottom layer, and I'll try and put some diagrams on the screen right now as we're going through this. But that Azure storage, one of the benefits of Azure storage, it's going to bring us the ability to have a durable and high availability or high available storage solution. It's going to bring security. It's going to be scalability. It's going to be managed. I don't have to know where those disks are or where that storage is, and it needs to be accessible. Then built on top of that, we can think about, and this is just to summarize everything I just kind of touched on, is we're going to think about Azure Blobs, our object storage. We're going to think about Azure Files, which is our NAS. We're going to think about SAN, so whether that be Elastic SAN from an Azure perspective. We've got the queues and we've got the tables. We've got those managed disks, but then equally we've got the container storage on the horizon. One thing that we're looking at supporting as well within that. What else have I made notes on? So I found, so if you think about storage accounts, they're a top level namespace for those storage services that I just mentioned. They're created in region, but there's different types of storage accounts. We have a standard, which is a general purpose, and then we have premium, which is a low latency. I'll let you decide which one you need. I would imagine that premium is going to cost you more, but you're going to have much better latency, whereas standard is going to be that general purpose. And that storage account, when you go into the portal, has to be unique in terms of naming, like obviously. It is also, if you think about the resiliency and all of these high availability, resiliency that I mentioned, that's great. That they will 100%, Azure will keep the lights on and keep your infrastructure up and running. What they don't do is they have this, so there is a shared responsibility model where the data is your responsibility. They do have native first-party tools that are going to just get the job done, but obviously from a traditional point of view, and I won't make this a plug around Veeam, but Veeam will give you a lot more granularity. Many of our competition would do as well, but we're going to focus in on those services. We're aware of those services, and we also want to give you the freedom of being able to restore them wherever you want. I can give you a bit of a spoiler around Azure Backup is only going to let you restore to Azure. It's not going to let you offload that somewhere else. So different types of resiliency though when it comes to a storage account. And you've got there was something said about interaction being lower than the assurance. So if you think about assurance of, well, that's a durability. So how safe is my infrastructure? How safe is my data? My data is going to be replicated here, there, and everywhere. Great. But if I replicate bad, then that's going to only replicate bad things around. So this is where you start seeing things like 11 nines or up to 16 nines, whereas that interaction would be lower. The other interesting part was around LRS. So LRS being 3 copies in the same availability zone. So if you think about a region having 3 data centers, so disparate data centers under the same region, and that might be UK South, and we have 3 data centers, so we're going to store a copy in each 3 of that. LRS is on one of those data centers, but we're going to have 3 copies in one of those data centers. So that's going to be potentially the cheapest model. If you need more than that, if you need to be spread across all 3, then it's ZRS, so 3 copies spread over 3 AZs. If we look at GRS, which is spread over to a second region, and in that case, we might have region 1 with AZ1, 2, and 3, and then we'll have region 2 with AZ1, 2, and 3, and we've got 3 copies of our data across 3 of the AZ1, 2, and 3 in region 1, and then we might have another copy of those 3 on just AZ1 of region 2. I'll try and diagram that as well. Then we have a combination where we could have GZRS, which is a combination of, I believe, having copies of that over the 2 regions again. Let me just confirm that. There are, so yeah, GZRS would be 3. I'll put some diagrams on so it all makes sense. If I had time to do a demo, this would be me just running through creating a storage account and highlight the above options. And I think we're nearly at 30 minutes. So blob storage, file shares, yeah, all good. Again, remember that size and performance. We actually have an open source tool called Kubester, more in line. It's a Kubernetes based storage, and this is where it becomes quite interesting. This is where I really cut my teeth on Azure storage, or in fact any cloud storage related to Kubernetes. If you think about a virtual machine is, well, a Kubernetes worker node or a control plane that you don't have access to here. So a worker node has an operating system disk. That disk is what we're talking about. That's going to be that managed disk within Azure. If that needs to be 50 gig, great. But if we're going to start putting storage onto that, like actual databases within our Kubernetes cluster or some sort of PVC, and we need a particular amount or a particular set of IOPS that we need to adhere from that, then we need to look at the size. Doesn't matter. We might just need to look at the IOPS. It depends on the performance, build up and stamp of your application at that point. What do you need? So Kubester actually is a CLI tool that runs within your Kubernetes cluster, and it will scan against your disks available or storage classes that you have available, and then report back and say, oh, you can get this amount of IOPS from it. It's much easier up front to go and do that test on to read the documentation and find out what disk is going to give you the application performance that you ultimately need there as well. Yeah, and I think that's it. But fundamentally, again, if we think about data on Microsoft Azure, data has to live somewhere. It's going to live on some sort of storage. And that's really what the cloud is built up upon: storage, compute, and networking. Obviously, we've just focused on that storage. Very quick whistle-stop tour. There's lots of different intricacies from that. I haven't spoke about things like Azure SQL, what offerings we have within that. Obviously, there's a load of places we can store some sort of data, and there's a lot of you that are going to be using that. But really, what we're getting at is that the Azure storage, great, we're going to offload. I don't have to look after disks or any storage arrays within my own data center. I can offload that to Azure. But what this really is around, okay, all of my data is going to sit on this storage that we've just spoke about. Then how do we use that, leverage that, protect that, and move forward from a business point of view? Because ultimately, again, that first step into the cloud, you might just go all in with virtual machines and then realize, Jesus, this is costly. And I'm seeing a lot of customers at that point pull the ripcord, go back on prem because they think that is they think that's the only way out, is that this cloud thing costs a load of money. Actually, what they should be doing was re-architecting and refactoring that into either more cloud native technologies, which is not the easiest. From a Kubernetes point of view, you can't lift and shift monolithic applications. That's another session for another time. But equally, how do I get into that Azure managed databases, or that Azure files, for example, or those native services, and think differently from that perspective? But yeah, hopefully that was useful. Like I say, hopefully I've recorded this voiceover first. Hopefully I get to put in some diagrams on throughout, and that makes it a little bit clearer about what I'm trying to talk about. And hopefully that was useful. If you've got any questions, hit me up on Twitter. I still refuse to call it X. I'm at MichaelCade1. If anyone wants to talk about data protection, data management, and just data in general, it's basically been my life for the last 9 years. I've been at Veeam for a while now. And I guess the commonality or the common theme that I'm talking about is, yeah, Veeam started with VMware. That was just the start. There's so much more. I look after the cloud and cloud native business. So from a technologist point of view, I'd love to chat to anyone that is doing anything in that space, and anything that we're missing or that you're looking to achieve. With that, awesome. Hope you enjoy the rest of the sessions. Thank you.